Good afternoon, class. So today I'm going to present on the district probability. District, the way district means that it takes exact values, right? So, for example, the number of tomatoes on each plant in a greenhouse. So, I'm going to the district probability distribution. Distributions. So we're going to do one, the binomial distribution. We have the binomial distribution. One, binomial distribution. Two, we have the Poisson distribution. Poisson distribution. Three, we have the geometric distribution. So I'm going to focus more on these three discrete probability distribution. We are not going to do the Binomial distribution because it was derived from this probability distribution. So we are going to do these three types of discrete probability distribution. So I'm going to start with the binomial distribution. So binomial distribution. So the conditions for binomial distribution or how to identify the binomial distribution, you will give the n conditions for binomial distribution. You will be given n in bracket the symbol size or the random symbol, the symbol size, and P, which is the probability of success. Of success. So given these two parameters, you can easily identify that this is a binomial distribution. So you are getting by N and P. So that is how you identify the binomial distribution if you give it N and P. So here you have to also know that the number of cells are independent. Independent cells are carried out. Outcomes are either success or failure. That's why we have P and Q. So here Q is the probability of failure. So, right. So here, finite number of cells, finite number of cells are carried out. So that is it. Carried out. So in binomial, finite number of cells are carried out in binomial distribution. So what we have to know is that we also have to know that P plus Q is equal to 1. So the summation of P and Q should give you 1. The probability of success plus the probability of failure is equal to 1. So P plus Q is equal to 1. This is the probability of success plus probability of failure is equal to 1. So Q is equals to 1 minus P. So this is very important in binomial distribution. So you have to also know that the formula for binomial distribution, the formula for binomial distribution So the formula for binomial distribution is n choose x times q to the power of n minus x times p to the power of x. So that is the formula for binomial distribution. So we also have to know that we can calculate the expectation using binomial distribution. So E expectation or the mean, E of x expectation or mean for binomial distribution is equal to NP. Then the variance for binomial distribution, variance for binomial distribution is equal to NP Q. So that is the variance for binomial distribution. So the first example that in a class of 10 students, 30% had done computers at O level. In a class of 10 students, 30% had done computers at O level. Find the probability that the teacher will pick exactly one student who had done computers at O level. So that is the part A of the question. Then the part B of the question says that find the probability that the teacher will pick at least one student who had done computers at O level. Then part C of the question says that the teacher will pick at most two students who had done computers at O level. Then part D of the question says that the teacher will pick more than two students who had done computers at O level. Then the fifth question says that find the probability that the teacher will pick less than two students who had done less than two. Then part 6 of the question says that find the expected number of students who had done computers at O level and the variance. After calculating the variance, then we calculate the standard deviation. So the solution for this question, the question of this nature requires you to use the binomial distribution. Why? Because you are given n and the sample size, which is 10, and the probability of success, which is 30%. So n is equal to 10 and p is equal to 0.3. So this is a binomial distribution question. So you have to say x follows binomial. You have to define the distribution first. X follows b 10 with p 0.3. So the first part of the question says the teacher will pick exactly one student who had done computers at O level. So probability of x is equal to 1. So is 10 choose 1 times q. The complement of this is we say p plus q is equal to 1. So in this case, p is 0.3 plus 0.7 is equal to 1. So if we want to find, so since we have 0.3, so if you make this one inside the formula, so the complement is 0.7, which is our q, 0.7 to the power of n minus x, which is 9 times 0.3 to the power of x. So I'm going to put this on my calculator. 10 choose 1 times 0.7 to the power of 9 times 0.3 to the power of 1. So this is the probability. 0.12 is 0.12 to 2 decimal places. Right, for 0.0, 0.121 to 3 decimal places. Right, so that is the solution for the first part. So I'm going to calculate the solution for the second part of the question, which says the teacher will find the probability that the teacher will select at least one student who had done computers at O level. So at least it means that 1 up to, from 1 up to 10 students, we have the same of 10. Since we say finite number of cells are carried out. So I'm going to say probability of x is greater than or equal to 1. So it equals to probability of x is equals to 1 plus probability of x is equals to 2 plus up to probability of x is equals to 10. So this method is too long. So we can simplify it by just saying 1 minus probability. So this is the alternative way of doing this, right? X is less than 1. Since the values of x in Binomial range from 0 up to infinity, so we can now say 1 minus probability of x is equals to 0. So it's now 1 minus 10, choose 0 times 0.7 to the power of n minus x is 10 times 0.3 to the power of 0. Any number with the power of 0 is 1, so it is now 1 minus 10, choose 0 times 0.7 the power of 10 times 0.3 the power of 0. So the answer is 0.97. So the chances are high of picking those students 0.972. So that is the probability. So I'm going to work out the third part of the question, which says the teacher will select at most 2. At most 2, it means less than or equal to 2. At most 2 students. We had done computers at O level. The teacher will select at most 2 students. We had done computers at O level. So at most, the sign for at most is probability of x is less than or equal to 2. So that is the sign. You have to know this sign. So it's now probability of x is equal to 2 plus probability of x is equal to 1 plus probability of x is equal to 0. Right. So we are now using that binomial distribution formula to calculate this probability. So it's now equal to 10 choose 2 times 0.7 the power of a minus x, which is 8 here. Then we multiply by 0.3 the power of 2 plus 10 choose 1 times 0.7 the power of n minus x is 9 times 0.3 the power of 1 plus 10 choose 0 times 0.7 the power of 10 times 0.3 the power of 0. So the summation of this probability should give us the probability for at most 2. So is 10 choose 2 times 0.7 the power of 8 times 0.3 the power of 2 plus 10 choose 1 times 0.7 the power of 9 times 0.3 to the power of 1 plus 10 choose 0 times 0.7 the power of 10 times 0.3 the power of 0. So this is the solution for this question. 0.38 is our final answer. 0.383 to 3 decimal places. So So that is the solution for the third part of this question. So we are now going before the part of the question which says the teacher will select more than 2 students. We have done computers at all. More than 2 students. We have done computers at all. So more than, that is the sign for that one is you have to say. So we have to know that. So